Well, good morning, good afternoon, good evening, wherever you might be in the world. And thank you for registering to our webinar today, Is Your Cable Strategy Future-Proof? We're absolutely delighted that you've taken the time out of your day to join the team of Paul, Lee and Barry. So without taking up further time, I'd just like to start the webinar with a few rules and regulations on how we enter into this. So we will have a discussion around the topic for around 45 minutes, and then we will open it to the floor for a Q&A to the panel. So make sure you put your questions into the Q&A there, and we will put them to the person that you feel or the right person to answer that particular question. So as I say, we're really excited to have you here to learn about our ECG technology. And what I want to do is to hand you over to Paul Cook, who is our Vice President of Renewables. So Paul can tell you a little bit about ECG and today's webinar. So Paul, if I can just hand you over.
Thanks, Spencer. Yeah, hi everybody. Delighted to be here and present to you on this webinar. So as Spencer said, my name's Paul Cook. I'm the VP of Renewables here at ProServe. My responsibility within the business is to lead, drive and deliver the renewable strategy for ProServe. I have a mechanical engineering background and I've been through various roles in my career across technical, commercial and leadership roles. Been within the business for 16 years. 20 years in the energy sector, and I'll now pass you over to Lee to introduce himself.
Thanks, Paul. Hello, everyone. My name is Lee Davison. I'm Product Manager for Renewables, working closely with Paul and Barry, who you're about to meet, specifically at the moment on our ECG cable monitoring product that you're about to learn about. Myself, 13 years in the energy industry, specifically offshore energy as well. And on the flip side to Paul, I come from an electrical, electronic and software background. Over to you, Barry.
Thanks, Lee. Yeah, my name is Barry Frost. I'm the Business Development Manager for the ECG product here at ProServe. Joined in the latter part of last year. Before that, I've had a few years working for a data analytics and insight company, specifically for offshore wind, a global company there. And my role essentially is to get the ECG product in front of the right people and see what solutions we can provide across the offshore wind sector.
Okay, thanks very much, team. We'll just crack on with the webinar now, some of the questions. So the first question that we've got that we'll put to the team, and I think Paul's going to pick this one up. Cable asset integrity strategies. We're going to discuss different examples and what does good look like? So Paul, over to you.
Thanks, Spencer. Let me just share my screen just now. There we go. Hopefully you should all be able to see that okay. I'm going to talk through kind of 3 distinct cable asset management strategies for inter-array and export cables within offshore wind, and more importantly, what good really looks like in practice. And as I'm sure the audience can appreciate, the difference between a reactive cable strategy and an optimized one can represent tens of millions of pounds, euros, dollars in value, but also have a significant operational impact, particularly around efficiencies. So with that, I'll walk through and explore three asset management strategies which are measured between predominantly risk, O&M cost, risk, revenue and O&M cost. And so the first strategy is split between high revenue, high risk and reduced O&M cost. The second one is medium revenue, medium risk and high O&M cost. And then we'll finally finish on optimized revenue, reduced risk and reduced O&M cost as well. Okay. So I've broken down the specific dimensions of what makes up or typically makes up a cable asset management strategy and scored them accordingly to what can be delivered between the implementation of the 3 strategies that we're walking through. So starting off with strategy 1, This is what I would call the sweat the asset model. So the philosophy is pretty simple here: maximize availability, defer intervention, minimize O&M spend, and generate as much revenue now. And the typical characteristics of this strategy are limited or no condition monitoring, which, driving a lack of awareness of condition integrity and performance of the cable system at any point. Minimal subsea inspection campaigns, or minimal to what is regulated today, and typically repairs are triggered by a failure rather than detecting ongoing gradual degradation and understanding the condition, integrity, and performance of your cable assets, and an operational acceptance of higher probability of unplanned and forced outages. And the strategy can often be driven through strong power price environments. So if there's a good PPA or a healthy PPA, then that's typically driven in this environment. There's high debt pressure against the project, and also portfolio operators are focused on short-term IRR, or internal rate of return. So, however, with adopting this cable asset management strategy, the technical and financial implications can be significant through the reduction of planned O&M costs, but subsequently, this is going to increase the exposure to things like emergency cable repair, vessel day rates, so vessel rates on the spot market, increase in insurance premiums due to multiple claims and high risk, unplanned outage risk, and also revenue volatility. And through this approach, export and inter-array cables typically degrade through electrical and thermal cycling through high and low loads on the cable, particularly around the terminations, mechanical fatigue around free spans in the environmental movement on the seabed in and around the cable section, burial loss and exposure, and third-party damage risk. And without having or having the ability to be proactive in your monitoring, these failure modes will progress and become apparent and completely undetected. And the result is pretty simple: that a single export cable, for example, can remove 100% of the revenue for months on end, depending on the severity of the cable failure and the intervention that's required. But ultimately, overall, this strategy works until it doesn't. So just to jump to strategy 2 now. So this is medium revenue, medium risk, and higher O&M cost. And this strategy 2 is what I define as traditional inspection-driven model. So quite a manual approach. And this strategy attempts to manage the risk through mainly routine physical verification of the assets. And the typical characteristics around this strategy is annual or biannual subsea inspections and periodic ROV surveys, manual topside inspections of cable terminations and the associated infrastructure, reactive corrective maintenance. So as and when something goes down, or there's something that's been noted that is a defect, then you maintain it. And ultimately, the reporting of this is very much a paper-based or a manual integrity register and reports. And the intent is to reduce the risk, but there's several inefficiencies to consider with this strategy, and that is ROV campaigns can be quite expensive. Typically, you're at the mercy of weather windows, and weather windows can be limited, particularly throughout the winter months. And the data collection is manual and periodic, and it's not continuous and real time. So ultimately, with this strategy, you're in this cycle of you inspect, you document and report, you repair if necessary, and then essentially you rinse and repeat. So that's that continuous cycle of what strategy 2 delivers. But the limitations around this particular strategy is you only see issues at inspection intervals. Any data available is often not integrated into live and automated systems, and various campaigns may identify symptoms but not necessarily the root causes of the failure. So surprisingly, this approach increases O&M spend, but is not proportionate to the reduction of the risk with this strategy. Ultimately, it's safer than strategy 1, but it's certainly not optimized either. And then moving to strategy 3. So this is optimized revenue, reduced risk, and reduced O&M costs. So this strategy is what I would define as the data-driven integrity model. And it's certainly, the best practice and best approach of the 3. And this strategy shifts from inspect and react to more of a predict, prioritize, and prevent approach. And the fundamental components of this strategy are continuous, or at least near continuous, electrical and thermal monitoring of not just the cable, but the full cable infrastructure, including joints, terminations, and various other supporting miscellaneous items on the cable system. Certainly, dynamic cable rating models would be implemented within this strategy. Real-time load and burial analytics. Potentially, other data and digital twin integration within the continuous monitoring system, and targeted inspection intervention campaigns are typically driven by, firm data, but also risk models as well. And with this strategy, you're optimizing 3 variables simultaneously at the same time, and that is revenue, risk, and the O&M cost. And by sorry, Lee, yes, jump in.
So just to jump in, what do you think the driver needs to be to move across to option 3? Because obviously, I guess the red herring, or not red herring, sorry, it's the wrong phrase. The elephant in the room there is you kind of need to spend more up front, or at least on your maintenance, to get those benefits. And I think in the short term, most people are attracted by the left-hand side, right? The spend less, make more money in the short term.
Absolutely. I think it's more around, having or understanding the value in the technology that is available to the market to be able to make real-time, better informed decisions to then have a significant impact on, O&M costs and spend. I think that there's a big opportunity for the market to understand that if these systems can be implemented and be implemented well, and you take a condition-based maintenance or a automated data approach, again, the benefits there are significant. There are newer technologies, and ECG is one of them, and obviously we're commercializing that. But the early indications are that this is going to be extremely valuable, and it's not going to be a manual process where there's significant operational intervention and disruption through not being able to understand the real-time condition, integrity, and performance of assets. But also, more importantly, the ROI at the end of it, in terms of a better return on investment for investors and owners. And also being able to, increase the availability and safeguard the assets for, particularly going into that later life area, and potentially life extension as well. So that's kind of my interpretation of it, Lee.
Thanks, Paul.
No problem.
So a good summary there of the strategies that outline the risk and exposure. So if you've got any questions around this, please put them in the chat. It's your opportunity to grill the panel, put them on the back foot, make them sweat a little bit, and get some questions in there. As I say, chat on the right-hand side. So moving on to question 2, and we're going to hand this one over to Lee. And the question that we're going to put to Lee is, how does cable monitoring support a proactive and evergreen cable asset management strategy? Bit of a mouthful there, Lee, but I'm sure you've got the answer. Over to you.
I hope so. Thanks, Spencer. So if we look at traditionally what's been happening specifically in offshore wind, you've typically find the export cable would have a monitoring system on it. And typically that would be a DTS, or distributed temperature sensing system, and that kind of makes sense, right? Because it's the key link to the grid onshore. So if that goes down, the wind farm is not able to export any energy. So that typically has been monitored with a DTS system. We're starting to see now more and more projects coming through requesting monitoring on the inter-array cables as well, which is good. Obviously, the wind farms are getting bigger. The generation from each turbine is bigger, so the impact of even a single cable going down is getting bigger and bigger. And again, if there is a system requested, typically it's DTS, which is a good system to have. Excuse me. It allows you to monitor any hot spots or cold spots, and that might mean the cable is become extra buried from a sandbank, for example, or become deburied by, again, sand moving and the cable's exposed. So it's valuable to have. You can also use it operationally to see how hot the cable's getting, obviously, to see how much power you're pushing through it, back to Paul's point about extending life and actively managing. And on top of DTS, those extra modules, depth of burial, thermal ratings, etc., are fairly, again, in the export, fairly common. The array cables less so, but slowly becoming more common. There's another technology also based on fiber optic called distributed acoustic sensing, which again is very valuable if it is used. The slight caveat with that is just the vast amount of data it produces. It could be gigabytes of data every day. So you really need to actively use and interpret that data, otherwise it becomes a bit not pointless, but a bit you can't really use it in a proactive way, right? You can use it retrospectively, looking at root cause analysis and things like that, but to actively use it takes a bit of managing. So just to finish off the current approach, then, when we have found several times the requirement to monitor it can be a bit of a box ticking exercise. So where there is a DTS system, as I just mentioned previously, it's not actively being used. It's there, but the data is not being utilized. It's just being gathered, stored, and then if there's an issue, it might get looked at. So again, back to Paul's point, being the proactive piece is the key thing here. I'm just going to share my screen, because the extra piece that we bring to kind of a holistic, a complete monitoring solution is as good as DTS and DAS are. Excuse my horribly out of scale sketch here, but hopefully you can see this is a transition piece at the bottom of the turbine. You've got your array cable coming in. Obviously, the power conductors will go off to the switchgear, and the fiber bundle will go off to a telecoms patch cable or a patch cassette somewhere. And because the distributed sensing systems are based on the fiber optic, you're not actually getting any visibility of the terminations, which depicted up here. And the research shows that I think it's around 2/3 of cable failures are actually related to joints and terminations. So it's a real key area to have visibility of. So what we add to the offering is, if I can get my animation, there we go, is to also add termination monitoring. And the system we use at ProServe is also fiber optic based, so it kind of fits perfectly with the other systems. And you can see here on the right an example being, we can patch the fiber out and we can place point sensors exactly where the areas of concern or the areas of interest are, and get super fast data points from every termination point. So this obviously just being an example. Every proposal we put together is different. Essentially, it's based on wind farm layout, sea conditions, seabed conditions, termination types, etc., and the client issues. So this is just an example, but hopefully you can see, just by adding that termination monitoring with the other distributed sensing systems, you can get a complete picture. And then what that means is, of course, again, linking it back with Paul's point, you can target your inspections, you can target your maintenance, So when you do have those weather windows, you don't have to routinely go around every single asset turbine connection one by one in the hope you find something. You can target the areas of interest directly, and then obviously if there's time you can check the other ones as well, but you should have good visibility of where things need checking, maintenance, inspections, etc., without having to manually go and inspect each one. Excuse me. So what that means is not only in the operation you can get these extra insights and learn about how the cable's performing, it also helps you potentially extend the life of that asset, because you've got a picture of how it's been performing, how it's been degrading, if it has, etc. And it can help you build that picture of how much life you have left in that asset. In much the same way, I think everyone will probably be familiar with gearboxes and bearings, etc. They'll be monitored for vibrations, temperatures, oil quality, etc. But the cable system is often neglected, in our view, in terms of having those data insights and the knowledge of what those assets are doing, because they're not, I guess technically maybe they are passive. I was going to say they're not passive, but they're not fit and forget, right? Just the sheer stress on these cables, because of the voltages and currents putting through them, they do have a defined life. And if you understand what's happening to them, you can then manage it better, right? And if you can't see that, you're essentially running blind on the key link. Sorry, Paul, go.
No, I was just going to say, I think it's also worth sharing with the audience that, you know, the implementation of this technology, particularly around what we call the DES element and point monitoring for across temperature and current. These are passive sensors in the way that they don't have to be powered, or there's no additional power infrastructure to power the instrument or the sensor itself, as well as there's no additional telecoms infrastructure required to get the data from the sensing source to essentially the interrogator, which then processes the information data. And it's all based upon photonics or light through fiber, essentially. So there's no additional equipment other than the actual sensor itself to be deployed around, whether it's the three phases, the earth sheath, or whether it's, you know, you're monitoring, you know, the T-boot connections for thermal measurements and the earth sheath as well.
I was just going to say, Lee, it's probably worth mentioning for the audience as well what that looks like from a user perspective. Say, for example, when this technology is installed, how would that look from a user's perspective?
Physically, do you mean, Barry? Sorry.
Yeah.
So physically, the temperature sensors are there's different forms of them, but essentially they're quite small, like smaller than a biro, really. Sensors just spliced into the fiber optic system. The current measurements that we take, they use a standard industry standard current transformer. We'll typically use a split core one, so we can retrofit around existing cables. We don't need to touch or demate or mate any HV connections. We can clamp around them, and then the secondary winding from those CTs will go to a passive secondary converter that converts that electrical signal into the optical system, and then is again spliced in. So as Paul mentioned, they're all passive. So once they're installed and spliced in, no maintenance is required. So, and similar for DTS and DAS as well, it's very well suited to wind, because you can centralize all the equipment on substation, and then you can monitor down the strings of turbines and the terminations as well. And pending any external damage, they're kind of fit and forget, really.
Any other questions on this topic at the moment?
No, what I'd like to do, Spencer, is just jump in with another slide and how this kind of approach, from a holistic approach, has a kind of a positive impact from you know, an O&M perspective. So I just wanted to put this slide up, and essentially it just reframes the same comparison from what I shared on my previous slide. And on the horizontal axis we have revenue, vertical we have risk, and then the actual bubble size represents the the total O&M cost exposure. So going back to the three strategies, and strategy one, it's positioned to the right because revenue can be high, but also on the there's also a significant exposure to risk with strategy one, given that it's very manual. There's no real-time data or any sensing technology that's feeding back any information on condition, integrity, performance of the asset. And although planned O&M is relatively low, the total lifecycle cost exposure can be significant due to unplanned events, and this is why the strategy one bubble is relatively large. And strategy two, which is essentially positioned in midfield, and revenue is moderate, risk is moderate, but the bubble size is the largest, which is reflecting on high planned O&M expenditure from reoccurring inspection campaigns. So typically continuously sending off people, certified individuals, to be able to inspect these high voltage assets. And then with strategy three, positioned in the bottom right quadrant, it's high revenue, low risk, and obviously the smallest bubble attributed to the O&M costs. So I guess what we're trying to represent here, and the key message, is that optimized integrity management is not about increasing costs to reduce risk. It's about using data and predictive analytics and being proactive to simultaneously reduce risk and control costs while maintaining revenue performance as well. And typically for owners and investors, this will prove EBITDA or profit stability, improved insurance positioning by demonstrating to the insurers that you're significantly reducing the risk through this proactive approach and strategy. Of course, from an investor perspective, there'll be debt covenant confidence as well. And then, of course, from a long-term perspective, you're increasing the asset valuation by understanding that it's in a good condition, it's been well maintained, and therefore it is a higher value and can proceed into kind of more of the end of life. And I suppose talking about that end of life point, Barry, that would be a good point to segue into kind of one of the points that you'll be covering. Over to you.
Yeah, thanks, Paul. No, as you said, like we've kind of covered the asset management strategy, so that operational side. We've looked at the current sort of cable monitoring systems out there, specifically ECG, and how well we can deploy that, and what that gives you in terms of returns. But yeah, one thing that we're hearing more and more of at the moment is that attention is now being turned towards that end of life. And this includes discussions that we're having at the moment, not only with developers and operators, but for offshore transmission owners as well. And it's a fact that a large number of projects at the moment will be will have that term decommissioning kind of stuck in the back of their minds. And there's a lot of early projects that are going to be, I guess, reaching that predetermined end of life date within the early 2030s as well. In terms of sort of what those dates look like and what the timeframes are around that, from an off-tow tender round perspective, anything from an off-tow tender round 1 to 5, the end date that was given there, or the license that was given for the off-tow, was 20 years, and it was only from the off-tow round 6 onwards that it was then gone up to, or increased up to, 25 years. There are discussions around at the moment from an Ofgem perspective that might be increased, potentially up in 5-year brackets as well. So, this discussion that we've kind of landed on here, looking towards end of life and life extension of projects, it is only going to sort of increase in terms of discussions being had. So, fortunately, the good thing is that Oftows and developers and operators are not going in blind, and Ofgem have released their project extension guidelines. Some of that I'm just going to go through now, but essentially that was a tender revenue stream document that was released in 2024. There's been multiple revisions and consultations around that as well. But just looking at the aim of what Ofgem are trying to achieve here, and I think the timing's pretty good, is they're looking to establish technical viability of projects, where they're at and whether they have the ability to extend. It's building business cases for project extensions. It's enabling that coordination between the different parties as well. So that's going from the generator side through to the OFTO and then over to Ofgem as well. And then ultimately, the outcome and the feedback of these guidelines will provide more information and help improve the regulatory decisions for when these happen down the line and in the future. So just to break that down, there's a number of milestones kind of located within this document, which I'll bring up now. Yeah, I'm sure we can all see that. And within there are these health reviews. So I'll go through this document in a second, but the health reviews essentially is where both the generator and the OFTO will individually perform their own health reviews. And these consist of a condition assessment of the transmission assets within the generator side and the OFTO side. So that's looking at the cables, the terminations, the OSP equipment and that type of thing. There'll be an evaluation of the operational life. So that's looking at the assets and how they have performed and any issues that have occurred through the operational life of the cable assets. And then identifying the required investments and repairs needed if life extension was to be granted, and then the overall cost for the extension as well. And again, another opportunity for knowledge share and information sharing between those three parties. So as we kind of move over to the image now on the slide, what can be seen here is that if you look on the left-hand side there, there's T minus and then a number. So what we've got is T minus 6. That is 6 years from the original granted OFTO license for when is the natural end of life for a project. So already you can see that it's not just or it can't be just a secondary thought if a project is looking to go and enter that life extension phase. There needs to be some serious considerations with a relatively long lead time before that date is becoming even close. So what can be seen here is we've got the health review and we've got the offshore wind extension protocols, which are outlined in this Ofgem guidelines. And initially, it starts with the generator having a conversation or outlining its plans for that extension and opening up the door essentially between both the OFTO and Ofgem. And it will start that process of building its business case and performing its health review, which we've gone through a second ago. From there, and obviously you can see from the image there, that's at T minus 6, so 6 years out. Also around that time is that agreement starts to be put in place, and this leads to the OFTO also beginning its health review. From T minus 5, so 5 years out, the health review deadlines are sort of clearly labelled there, and then we'll have that sort of sharing process of information. We then lead to sort of 4 years out, or T minus 4, where Ofgem will give its minded to decision and any additional actions or commitments from the OFTO. This is probably the point where the OFTO may be changed or a new tender process may be sort of put into place there. And then around that sort of final sort of T minus 2 years, that's when it's kind of like that final decision period. So either there'll be an alignment and agreement that the project will then move forward with its plans for life extension, or it will simply revert back to the original plans in terms of the decommissioning of the project, and then it will be kind of linked and passed over to the DES-NZ. I'll just move over to the next slide. 2 seconds. There we go. And so this kind of aligns nicely, really. So this is just looking at the cable failure risk over the sort of the life cycle of a project, and we've added in there the sort of the life extension period as well. As you can see, the increase of risk failure does increase quite substantially as project age increases. Now there are multiple multiple infographics that are similar to this. You've got a bathtub curve, so it's quite hard to say, and different data sets. But ultimately, what it's saying is that as time increases, the risk increases substantially. What you can see on there as well is that you've got the global average age of offshore wind farms are 7 years old. But I've pulled out there the UK average age, which is actually 11. Now, this is an average as well. So there's two elements to this, is that there will be a number within that average that are further to the right and are slightly older in age. And also a number of those projects will only have that original 20-year OFTO license. So they will very soon be coming to that end of life period. So, we sort of said that, early 2030s, some of these end of revenue streams will be occurring. Well, if that's 2032, then these processes outlined by the Ofgem in terms of these guidelines will need to be considered in 2026. And again, if the end of revenue stream is 2034, 2035, there's only a couple of years really to get sort of everything aligned in order to start this health review process, if life extension is going to be considered. So just to kind of summarize, really, we're kind of entering a stage here with multiple projects that are seen to be approaching that T-6 period. And from an OFTO and sort of and a generator perspective, it's making sure that they have, from a cable perspective, that holistic cable monitoring system in place to be able to monitor the health, integrity, and performance of their cable infrastructure. It's why is that important? Well, it's going to ensure that you've got long-term data, which means that your assets have been managed properly, they've been maintained properly, and they're overall in general good health. And it's also got that potential cost saving there as well. But ultimately, it allows for either the generator or the OFTO to successfully complete their health review and that entire process as a whole, and gives them confidence within their assets moving forward, that they know, that they can continue that for another 5, 10 plus years into that life extension period.
I think that's a really good point, Barry. And I think taking the T-6 years point, particularly around the wind farm asset health review, which is essentially stage gate number 1 that you need to achieve in order to, extend life. I guess let's not underestimate the level of, work that would need to be involved, and the intrusive nature of a review of, cable infrastructure health and performance, without having any data-driven analysis. If it's all manual and all, done by hand, so to speak, and human intervention, should we say, there's going to be a significant amount of downtime that's required to access terminations, joints, and, also, very expensive ROV campaigns that will need to take place in order to understand the condition at that point to then justify the life extension through the Ofgem guidance. So, the earlier the asset can be monitored holistically, more data, more information around the temperature, the electrical nature, and the thermal aspects of the asset, the better.
Yeah, no, absolutely. And, again, it falls back to, the slide that you sort of showed, looking at the sort of the asset management strategies where, yes, you can go high risk, get that instant revenue, high reward, but is that going to be a long-term strategy for effectively moving into that life extension period?
Yep.
Or the optimized strategy where you've got a cable monitoring in place like ECG, it completely smooths that out, and actually the long-term gain far outweighs that short-term hit of income and revenue. So
absolutely.
I think just
That's
to add
great.
as well,
Sorry, Lee, sorry.
Just one point quickly, because I think I guess maybe, Paul, it fits in the middle of the three strategies you described, but ultimately they might want to run the system or sweat the asset, run it hard for a certain amount of time. But if you're not monitoring it, you don't know what you're doing. So you might actually not even be stressing it as much as you think you are, in which case you could push more power through it, or you actually might be doing quite a lot of damage. But if you're not monitoring it at all, you're completely blind to that. So even, obviously we think you should do at least the middle one, but preferably the full monitoring solution. But yeah, if you're totally running blind, you don't know what you're doing. You could actually be getting more out of it, but you're being cautious, right? Sorry, Spencer, back to you.
Yeah, thank you very much. Some really interesting observations, comments, points of view there. What we'll do is we'll hand over to the Q&A now. We've got some interesting questions coming in. So I'll just put those to the team. Let me have a look here. So we have to go with the first question from Stuart Windmill. I'm not sure that's probably Stuart's surname, but it's a very good one if it is. And Stuart asks the team, would there be any specific benefits or use cases for electrical distribution in oil and gas, maybe HVDC or HVAC? Who would like to answer, Stuart?
I can chip in from the beginning, but I know Paul probably knows more on the pipeline stage, but I think they already are, is the short answer. I forget the proper name for it in the North Sea. Paul, it's probably on the tip of your tongue. What's the name of the power to offshore oil and gas power?
Are you talking about Hywind Tampen?
Well, that's the project I was going to. But there was an auction round specifically for power for INTOG. Thank you very much. Yeah. So as I've just demonstrated, Paul knows more about that. So I was going to say it's already happening. Equinor have installed a wind farm, Hywind Tampen, which powers a series of oil and gas platforms in the Norwegian sector of the North Sea. Coincidentally, we do have a monitoring system on there as well. So I believe that they're getting value from that. We're in conversations with them to maybe improve it even further and monitor extra cables linking the platforms together. But it's absolutely already happening there. And I'll leave Paul because he knows more about the INTOG piece. But it's hopefully going to happen wider across the oil and gas in the UK sector as well.
Yeah, absolutely. I mean, this technology in ECG for ProServe has been ultimately led by offshore wind first and foremost, but there's a range of applications adjacent, within the broader energy sector that we're targeting with this, whether it's, interconnectors, long range, thousands of kilometers of HVAC and HVDC interconnectors. We also have things like subsea substations, obviously in time. The next 5+ years, particularly going into the mid-2030s, there's going to be these kind of transmission hubs offshore and located subsea. So there's absolutely value and an applicable market for this technology to marinize it somewhat and then put it into a subsea distribution or a subsea transmission system. And there's various other oil and gas applications across umbilicals and other areas that we're looking at in oil and gas where this technology can add value to. So yes, predominantly offshore wind focused, but we're absolutely looking in other areas across the broader energy sector as to where we can deploy this technology.
Okay, thank you. Great answers. Hopefully, Stuart, that answered the question that you posed. And Stuart, thank you very much for putting your question in there. And incidentally, if anyone on the webinar has any questions after the event, we'll make Paul, Barry, and Lee's contact details available so you can ask them directly. We'll also upload this webinar to proserve.com so you can share it or revisit it if you've had to drop out or you've missed any of it. So it will be available after. So the next question we've got is from Mike Gallo. First of all, thank you very much, Mike, for taking the time to put your question into the team. And the question from Mike is, to what extent does the Strategy 3 reduce the need for physical inspection of assets? Can the panel give us some metrics to quantify this? i.e., instead of inspecting once a year, you could twice a year, no inspection at all required, and so on. So who from the panel would like to pick up Mike's question?
Yeah, I can jump in there. So I think with a full deployment of sensing across a typical termination, and that would be summarized as phase current, sheath current, phase temperature and sheath temperature and ambient temperature, I think across those characteristics of the termination, you're essentially able to have a wind farm wide holistic view of the condition, integrity and performance of these terminations. So you can see the electrical performance, the thermal performance, and if you've got the ability also to tap into the voltage at the switchgear, you can then correlate current and voltage to then have an output of power quality. And power quality is a very, very important metric to understand how the generator is performing, and if there is poor power quality being transmitted through the cable infrastructure, whether that's the turbines or the cable itself, the likelihood of that leading into a mechanical, over time, leading into mechanical degradation and therefore a failure is relatively high. So you've got that holistic wide view. You then have the ability to understand which asset or which termination is deviating from its norm, or which one is behaving in an abnormal way compared to the rest. And the more strategic and proactive approach is to then inspect that particular termination, as opposed to just having a regular maintenance routine, and we have to inspect string number 2, turbine number 4, because it says so in my inspection routine. So it's a much more targeted approach to more condition based, I would say, to really target the areas that are behaving abnormally or potentially are close to failure, as opposed to just following a typical routine inspection schedule, which is not optimized. It's very inefficient, and with this, that you have the ability to target the problematic areas, and of course then decrease your O&M spend at the same time.
And just to add to what Paul was saying there, and taking this to the complete other end in terms of return on investment, right, is you've got a relatively large scale wind farm. The vessels and the cost of vessels and crewing those vessels alone on a relatively basic O&M strategy for cable maintenance without any sort of cable monitoring system is almost like trying to find a needle in a haystack, because the sheet says I need to check this array cable and that part of the export cable, but the expense is astronomical, and it's only going in one direction as well, especially as more wind farms are being built. The supply and demand of vessels generally is not working in the operator or OFTO's favor. So that cost is only going to be going up, whereas with a system similar to ECG, you're locating the exact problem where on the wind farm that needs your attention. Okay, so it's completely optimized, not only in the strategy, your O&M strategy, but it's also optimized in terms of your revenue, your lack of downtime if there is an issue, but also just generally over time, you're not paying out, or you're not having to constantly have vessels on site, which is more crew on site, which has a safety element as well. You are completely consolidating and optimizing that, which is is a huge benefit.
Great, thank you very much. We've got some other questions that have come in. Kevin Green from Adura has asked, how does ECG compare to traditional monitoring systems? Who would like to pick that up?
I can start it off. So I think the simplest thing to say is, and I don't think we covered it, but we maybe can. ECG was first developed from an industry challenge, led by
ORE Catapult and Scottish Power Renewables.
Yeah,
yes.
Thank you, Paul. Basically acknowledging cable failures are an issue. How can this situation be improved? Brilliant. Thank you, Barry. How can the situation be improved? And as I mentioned in the sort of traditional approaches, we have found instances where there is a DTS system installed, for example, but it's not really being utilized to its full potential. I'm sure you can imagine, the operators of this wind farm, and by that I mean the literal people in the control room, they've got multiple screens, multiple systems. They're trying to operate that wind farm to its best potential. They're not necessarily cable experts or experts of these different monitoring systems. So ECG was developed from this initial sort of call to action. And the approach we take is we literally specify or design a system based on every proposal. So at the annoyance of our proposal team, pretty much every proposal we put out is different to some degree, right? Maybe different types of technologies, maybe deployed in a slightly different way, because it really depends on what the operator wants to get from the system as well. Because of course you could throw everything at a wind farm in terms of monitoring, but being realistic, it's just going to be too much money. So it's about taking an approach of where is best to deploy the technologies and how is it best to configure them and use them. So we try our best to work with our clients and the operators as well, if they're not the same people, to understand what they want to get from them. So we kind of take that approach that they don't have to be cable monitoring experts. We can take that burden off them and just give them a system that's nice and simple and easy to use, and they don't have to understand. As I said, some of these systems are putting out gigabytes of data a day. The operations teams haven't got time to trawl through that. So I'd say that's the main differentiator. I don't know if Paul or Barry want to add anything.
Yeah, I think it's also, there's industry statistics that haven't changed much, particularly over the last 5 years or so, where 70 to 80% of insurance claims are attributed to cable failures. And then if you dissect the some of the failure modes that sit within that, they're particularly around the termination area. I think the statistic is that 2/3 of cable failure are not the cable itself, it's actually the terminations, essentially where there is kind of human intervention, if you like. And traditional monitoring systems in DTS and DAS do not have the ability to monitor termination. So with the integration of the point sensing and DES technology through our strategic partner Synaptech, as well as the traditional monitoring system, and that as an integrated solution. And then sitting above that, we then have the ECG analytics and software, which essentially simplifies, as Lee said, kind of the message to the operator within the control room, who typically would not be a cable asset expert. They have the ability to understand ongoing gradual degradation. They're able to identify deviations from the norm before it becomes a catastrophic failure, and they're able to react and put the issue right and react on that through a much more effective real-time process. Whereas traditionally, the traditional systems may only give you 10-minute averages. It may only give you kind of isolated areas of what how the asset is performing and its condition. But this integrated solution and the software that we've developed around this is ultimately giving you that holistic view, and in real time as well.
Just a final point from me on that is another sort of benefit to ECG is the fact that it's OEM agnostic. So, whether you've got a brand new project or a project entering end of life, as I like to keep banging on about, and whatever set of technologies or anything that's sort of embedded, any legacy project, any legacy equipment that's in there, ECG can be implemented, and it accommodates that, and it can be easily used and installed within that. So, really important to sort of learn that as well.
Yep.
Great. Thank you. Thank you, everybody on the panel, for your input, and thank you very much for the question. We're running out of time. We've got 5 minutes left on today's webinar, so we've time for one last question to the panel, and then we'll summarize, and we'll thank everybody and let everyone go on to the rest of their day. So the final question, and this is from Anonymous, but this is to the panel. So it's clear you can monitor the cable's performance. Do you also look at providing emergency response plans if cable failure is experienced, or general annual maintenance plans for the cables that operators can include in their O&M plans? Who would like to to answer that one.
I can pick that one up, Spencer. I think it's just to be clear with the audience, ProServe is a controls and monitoring technology expert. So we know what good looks like in terms of sensing technologies, controls technologies, particularly in harsh environments, subsea environments, and of course, offshore as well. The services that we provide through ECG are very much from a sensing and data and information perspective. ProServe do not necessarily react on the back of and deploy, cable asset management teams or certified technicians with, HV certification to be able to go off and then rectify the issue or the ongoing gradual degradation that the ECG system is reporting. But what we do and what we can do is partner with HV contractors, duty holders of the O&M across the OFTO and also the generation side to be able to offer that holistic package, if you like. So yes, we're providing the information and the monitoring and the condition integrity and performance, but also as a part of that kind of package, with a partner, we can also offer the response on the back of that as well. So ProServe are very much kind of in the sensing and data interpretation and information providing area, but we can obviously partner with HV contractors and duty holders to give that holistic service as well.
Thank you, Paul. Barry, Lee, anything to add to that?
Nope. I don't think so.
Good.
Okay, on that note, we'll just summarize. So today, the webinar was, is your cable strategy future-proof? And I think that hopefully for the audience attending and taking the time out of your day, you've found out a little bit more about ECG, about ProServe, and the opinions and the thoughts from Paul, Barry, and Lee. But just to summarize, so some of the topics that we covered off in today's webinar. So we talked about what is ECG and some examples of the benefits from this particular technology. Risk versus reward from Paul, and where's the value in this particular solution. Strategies for implementation and the upside, and for your own O&M strategies. And from Barry, regulatory guidance and key milestone dates and cable failure risks. So hopefully you've learned something today. Again, thank you so much for attending the webinar. We're on time, which is fantastic. And as I said earlier, if you want to revisit the webinar, we'll post it on proserve.com. Also, if you haven't yet, if you want to follow ProServe on LinkedIn, there are regular updates on ECG and a number of our other technologies, products, and solutions. And we'd love you to follow the business. And yes, finally, thank you very much to everybody once again. And I hope you enjoyed today's webinar. And we look forward to seeing you again. So thank you very much to everybody. Thank you.